This is a quick tutorial on how to add a delay, a delay active and then a turn off command for one TTL line in the trigger scope. This is using 602, firmware 602. I'm going to scroll down, and I tried to write the code. It's kind of, they're bringing updates into it, but I tried to write the code in a way that you could easily get to the programming menu. And well, as you can see, I just went right through it. Let's see here. So there we go. This block runs the high-speed control interface. Now, if you're using like a vanilla version of Arduino, the colors will be different, but the text should all be the same. The gray stuff here is commented out. If we come down here, we'll see this. The first thing we're going to see is this while trigger armed. So inside this routine, if I click the little bracket here, I can find the opposite bracket, which you'll see comes all the way down to, I think, right here. That's in trigger, so let's keep going. Maybe all the way down to here. Yeah, there's while trigger armed. Okay, so all of this stuff happens when you send the arm command. So the first thing that happens is we send the arm text, that flags trigger arm true. All right, what occurs? The first thing is we issue a timeout update. This just sets a LED flashing thing. Then if that's all that occurs, then there's this in trigger block. Now the in trigger block is used only if we receive an external pulse in from our system. If we don't receive an external pulse, then we skip all that, and what we do is this stuff, and there's not much to it. So here we have, we turn off the trigger in case it got forcibly turned on. That's just to make sure that we isolate the two blocks. We reset the timeout. And then let's see what else happens. We have this thing here that says while we have not received a trigger, wait for the next pulse. So if millisecond is greater than the timeout, then we throw a no longer armed command, and then we reset the max program loop back to 0 or 1, and we say, hey, the timeout succeeded, and then everything turns off and we break out. In the meantime, we flash our little LED on and off. Now, if we exceed our maximum program lines, then we also break out of the trigger armed sequence. And that's it. So that's the stuff that can happen if no pulses are ever received. However, what happens if a pulse is received? So then we come up back here. So if we get a trigger, then we run through this first the focus array, depending on whether it's master, slave, positive, negative. And then we run this update here, which goes through all of the TTL and DAC lines. So this walker, it's named walker because it walks through the TTL and DAC lines. And so you can see that it'll do a DAC write to whatever DAC channel is assigned to walker, which is 0 to 16 or 1 to 16. And then also it's going to do the same thing with digital write direct on the TTL lines. Okay, so this is what we care about. Now, we're going to assume we get a trigger, and we're going to go through all of our lines and change our states. And when we're done with that, we're going to end up hanging out over here. So there's a couple ways we can do this. One way, it's a little bit more dangerous. By dangerous, I mean you need to remember that you added it. But let's say that we let this update run. We also let the update for focus run. And then when that's done, we have this delay array program. So this here specifies a delay. So one option here is you could add into your del array, so like prog, I think it's prog underscore del array or prog underscore del, will add in a delay line for each program line. So imagine that you made that 5 milliseconds. Okay, so then what you could do is you could say immediately after that, we could just do a little command that said, just copy this, digital write direct. TTL will no longer be walker, it will be, let's say it's TTL line 4. And then we don't want to use whatever's pre-saved, instead we just want to write it low. So we'll say low. You can also use 0 and 1. This is a Boolean for on or off. Okay, so let's say it's 0. Okay, so what happens? So the This assumes, of course, that the line is raised high using your programmed, so you do like, before we ever do the arm command, you send prog_ttl, and then the program line number, which could be 1 through 50, and then, or maybe it's TTL line number, and then the program line number, and you'd say, set it to 1. And then as the programs execute, it sets it to high output, and then you've pre-programmed your delay, so you've set that for 5 milliseconds, so we just sit here for 5 milliseconds, and then boom, it writes back to low, and away you go. So what happens? Well, and a trigger response occurs here. The next trigger event comes. If you've told it to turn back on the next program line, then we repeat our operation. Okay, what's dangerous about this? Well, number one, what if you want to do something else with that line? That's kind of annoying. The second thing is, do you really want to delay here? Maybe you do, maybe you don't. This pauses all interaction with the trigger scope. So for instance, if you set this delay to 5 milliseconds or 3 milliseconds, and you really later need to do something faster, well then, what do we do? So I can kind of show you a workaround for that, but this is the simple answer for today, probably the one I would recommend using. Let's look at a more advanced answer. Okay, what I'm going to do instead is, when I get to here, I'm going to write something here, probably up in the beginning of this guy. We'll do an unsigned long variable, and it will be, let's call it an off timer. And we're going to set that to equal 0. Okay, so we've created a variable. Variable has the same digital size and specification, meaning like its range of 0 to whatever number. It's a long int, and we've called it a name, which is off timer, and we've set the timer to 0. Now this is living inside this trigger-armed function. So after we exit the trigger-armed function one time, this does get destroyed. So that's something to understand. But that's okay. It's going to live no matter how many trigger sequences we get here. Okay, so we get our trigger, we get down to here. What I'm going to do is I'm going to say, once you've written our TTL and DAC lines, maybe even your focus line, we'll go ahead and go down here. We'll say off timer is equal to whatever the current internal time of the microcontroller is. Okay, so let's say the internal time is 70,000 milliseconds or something. It doesn't matter. Now we've captured that time point. So down here, we close out of our trigger response and we go back to our wait timer, which is here. So this is where we're locked, waiting for our next signal. So what we can do here is we can do an argument. And we'll put this argument maybe inside this loop. This, by the way, is going to execute very fast. And we're going to say if off or millis is greater than off timer plus, say, 30 milliseconds, 20 milliseconds, something like that, then digital write, or we can do our digital write direct, which is a faster command. So we'll say digital write direct, and then whatever TTL channel we want. So we'll use TTL line. We'll address the array here and say TTL number 4. Keep in mind this is 0 indexed. So TTL 0 is really like TTL 1 on the trigger scope. So we'll say 4, which is TTL 5 on the trigger scope, and we'll say set to 0. All right. Inside of a execution block like this, we always want to have our close paren there, and then our terminator, and then we're going to close our braces. So we close the argument. All right. So what this does is it says when the timer is greater than our recorded time plus 20, in this case, milliseconds. So we're 20 milliseconds into the future. Then write this thing to 0. Now, one thing to note is that this will occur every single time this block runs, so it's going to end up setting this thing to 0 like a billion times before the next trigger event. I don't really like that, so there's a couple things we can do about that. One is we could say, what we could do is actually set the off timer to some insane number after this. So we could say like off timer is equal to millis plus 1,000 or 500 or something like this. So that way it should never reactivate inside this subroutine. So it writes it low once and then it writes it into the future so far that it doesn't matter. Now, do we care about that? Well, yes and no, because this is kind of like what I would consider to be kind of like a hack. The right way to probably do this is assign it a Boolean and then flag it off. But, with the risk being that somehow this executes twice, I don't really even see that being a problem. But it's just something to think about, is like how you want to flip your switches. The next time we come back up here, it's not going to matter if this is set to some humongous number because we write it directly here. So it doesn't really cause any failures. Okay, so those are two different ways that you can solve this problem. I'll go ahead and probably implement the first way and then send you that code. But I want to just show you how I think about this stuff. Because that way, like, if you can do this on your own, I think it is more advantageous, and you have a lot more power in how you implement your solutions. So that's it.